the quadratics. Would you even think of doing this by factoring? I mean, no. I mean, you know.
I actually tried it first.
Did you really?
Yeah.
Okay. All right. All right, I have two things I want to do, all right, and I just wanted to show you, and, you know, it's always about time. What I'd like to do is I'm just going to show you quickly, what?
Number 9, isn't it?
Number 9?
Number 9.
Where's, what page? 359? Where's number 9? 2x? Nine. Okay. And, all right. So number 9. Okay, this problem 2x squared minus 5x equals 4. Okay, I rewrote it in standard form. I wrote my formula, and I just plugged in. And minus 5 squared is 25. I can see here a negative and a negative is going to be a positive. So 4 times 2 is 8. 8 times 4 is 32. 25 plus 32 is 57. What kind of a number is 57? Prime. There's nothing I can do with that.
You can't do it, right?
What I would do, that is the most precise answer, just leaving it. I mean, what would you have simplified that to? Decimal?
Yeah. Well, that's what we done the last one.
Well, we were looking for something in particular. We were looking for the radius, and we were asked to round to the nearest hundredth. Okay, in this case, I can't find the square root of 57, so I would leave that. That's your most precise answer. Okay? All right.
Wait, it's not a prime number.
57, what two numbers multiplied
3
together?
and 19.
3 and 19. Okay, but, all right, so,
Yeah.
but if I broke that down into 3 and 19, would I be able to do anything with those? I'd end up with 2 prime numbers, so you're right. It isn't a prime number, but I can't simplify it. Good. Okay, so what I want to do, and I have to say I made a limited number of copies of this. I'm guessing most of you really don't care. Okay, most of you probably don't, but I would like to show you the mathematical equation that went into creating the quadratic. And talk about elegant mathematics, this is it. And as I said, I'm not asking you to do this, but I would like you to see it. So if I could just have your attention for a few minutes, I will then give you your homework, okay? So it should take me maybe about 2 minutes to do this. All right, so you know that we start with ax squared plus bx plus c. We're going to subtract c, let me see, is this right? Okay, subtract c from one side, because I'm trying to get to what? X by itself, that's my goal, all right? And then I'm going to try and divide both sides by a. So if I divide ax by a, I get x squared. If I get bx, I have b over a times x, and I have minus c over a. Okay, so far so good? Nothing, no magic. Now this next step is about completing the square. And I know that this is a really oddball, it looks horrible, but we know that when we have this number, if I have x squared plus some number, what am I doing to that number? Am I dividing it by 2 to make my square? So that's all I've done here, is I've divided it by 2. And
You get b over a.
I will get b over a. Okay, so I just want to show you what that looks like. So I had b over a divided by 2, Okay, and I know that b over a divided by 2, b over a divided by 2, what happens when I'm doing that kind of a division? I'm going to use the reciprocal, and I end up with b over 2a. So all I did was I cut my term in half, and I have the two terms. What happens when I have those two terms? When I'm completing the square? All right, so what I've done is, this is what I have. I know that it's going to be squared. Whatever this number is, I have to add it to the other side, okay? And I'm going to take you all the way down to here. So this is what we have. We've completed the square, and now I can write it like this. Okay, now I'm trying to get what by itself? X, okay? But it's within this parentheses and it's squared because I've written this as a quadratic. I'm trying to get this by itself, and I know that if I square, whoops, sorry, I think I skipped a step here. I have to back up a little bit. I want to have a common denominator, sorry. And so all I did here was I multiplied b squared out, and 2 right over here with an exponent here, that means 2 is squared and the a is squared. So 2 squared is equal to what? 4. So I have 4a squared. I want a common denominator. We're almost done.
How would you ever like think to do something? Yeah, exactly.
You wouldn't, but they've been using, somebody did, and they wanted, some mathematician, thousands of years ago, came up with this, and we are still using this. So I just want to impress upon you, they found a common denominator, okay? And so now I have minus 4ac over 4a, and this is b squared over 4a. But look at what I want to do. I just want you to hold on a second, Michael. Okay? So this is squared, and I want to undo this. And if I square one side and I have to take the square root of the other. And what is the square root of x plus b over 2a squared? It's going to be itself. Okay, and so this is what I end up with. Do I want x plus b over 2a? No, I want to subtract that. And that's how we end up with this formula. I mean, it's amazing. I mean, I wouldn't ask you to do that, but I think it's important for you to understand that it did come from that. So if you are interested in it, I made about 10 copies. And I'll let you pick one up if you're interested. Anybody interested or care? Stephen?
I tried doing it from the quadratic formula itself, but I ended up with ax squared plus b squared equals ac. So
you need to really understand the rules of algebra, and that there's nothing in there that we haven't learned. The only other thing that we haven't really done, which we will be doing, is if we have something that's squared and we want to unsquare it, we would find the square root of it, and that's what we did here. We found the square root of this, and if I find the square root of this side and I take the square root of the other side, then I maintain that balance.
So the purpose of doing that is just to get a more accurate answer for x.
It's so that I can find x.
So wait, this slide, like, is that homework from the book or anything?
I'm going to give you a worksheet, believe it or not. And, yeah. Okay, would anybody like that proof? As I said, I made a copy of it.